Now let's talk about layer 2 scaling solutions and why these are important for you to understand as a blockchain developer. So in the last video, we talked about Ethereum compatible chains or EVM compatible chains, which essentially are brand new blockchains that operate independently of Ethereum that have their own cryptocurrency where you can put Ethereum smart contracts and, use a chain that costs less money per transaction and also can process more transactions per second and make it faster. So, that's one strategy. Another strategy is scaling Ethereum itself so that when you use Ethereum, it's cheaper and faster to use, because one of the biggest complaints about Ethereum is that it's, kind of slow. We saw earlier in our presentation on Ethereum that it only processes about 15 transactions per second. All right, it has a block time of about 13 seconds. So essentially what a layer 2 is a separate blockchain that sits on top of another blockchain, which is a layer 1, okay? So in this case, a layer 2 scaling solution for Ethereum, would sit on top of Ethereum itself. So layer 1, in this case, would be Ethereum, and then layer 2 would be this second environment that processes transactions and settles the state, but still piggybacks off the security of Ethereum itself, okay? And in many cases, what you're doing is creating lots of different transactions that are rolled up together and put back on the main Ethereum chain in a batch. Okay, so that is what's called the roll-up strategy for Ethereum scaling. And roll-ups are what were proposed by Vitalik Buterin, the mastermind behind Ethereum, as the end game for Ethereum scaling. So people talk about needing to wait for Ethereum to get finished in its final complete form before it can improve the scalability problem, make it faster and cheaper to use. That's not really the vision for Ethereum long term. The vision is to use these layer 2 scaling solutions, as we can see proposed by Vitalik himself here. So unlike the other EVM compatible chains, which use their own cryptocurrency to pay for transaction fees and settle transactions on that chain, in most cases, on the layer 2s, you are paying transaction fees with Ether, or the native cryptocurrency of the Ethereum blockchain. So whenever you're doing transactions on layer 2, you're paying those fees in Ether, and then those fees go back to the validators who are running, the Ethereum layer 1 chain down here. So an example, if you wanted to use a layer 2, let's start with the perspective of layer 1. We can go look at our diagram here. Let's say you want to send cryptocurrency from one account to another on Ethereum layer 1. Essentially, you create a transaction and you point your wallet to Ethereum, and then you send that transaction and you sign it, and all the nodes in the network confirm that transaction and they include it into the base Ethereum chain. So on a layer 2, what you would do instead is you would point your wallet to the layer 2 itself. Okay, you'd do that transaction. It would be cheaper to use. It would get settled really fast, and then your transaction, in many cases, now some layer 2s work differently, but I'm going to talk about roll-ups, which is the most common one. We'll explain that in a second. Your transaction, along with many, many other transactions from other people, are all going to get batched in together into a single batch, and that's going to get included back onto the main Ethereum chain with a single transaction that includes information about lots of other transactions. Hence, they get rolled up, and that's how you scale, is you include more information in a smaller footprint. Let's look at an illustration of how the basic concept of scaling works. Okay, so this is going to be a little bit abstract. This is not going to be the exact values or anything like that, but this will at least illustrate the concept. So let's think about layer 1 Ethereum. This is just the Ethereum that you would be using directly without a layer 2 scaling solution. And let's pretend that we have 4 blocks in this blockchain: block 1, block 2, block 3, block 4. And again, don't forget, the blockchain is consists of transactions, and these transactions are grouped together into bundles of records called blocks, which are chained together to make the blockchain. And so let's just pretend, for example, that each block only holds 10 transactions. Okay, so it holds a lot more than that, but that's just an example. So if you were going to, do a transaction on Ethereum, Ethereum has a scalability limit in this make-believe scenario because it can only fit 10 transactions into a block. So if you want to send cryptocurrency from one account to another, you might be one of the 10 transactions, maybe transaction 1, 2, 3, et cetera, that gets grouped together in this block. And so if you're transaction 11, then you have to wait until the next block, and so on and so forth, okay? And, this is going to limit how many transactions per second that you can possibly do, and so that's going to make it slow. All right. It's also going to make it expensive because the Ethereum gas fees depend upon how many transactions are trying to go into the blockchain at any given point in time. So a layer 2 scaling solution fixes that problem. It scales it. So how does scaling work? Well, like I said a second ago, one way that you can scale is to take existing infrastructure and put more information into a smaller footprint. Okay. So what if you could include, many more transactions into a single block? Well, that's essentially what you can do with layer 2 scaling solutions. So you're not necessarily putting more transactions into a block. What you're doing on a layer 2 is, valuing the transactions at this layer 2 level, but then you are proving that each batch of transactions is in fact valid. Okay. In many scaling solutions, okay, some work differently, but generally speaking, what you're doing is proving that each grouping of transactions is valid, and that's a much smaller footprint of information than all the transaction information itself. And whenever you can prove that those transactions are valid, you can do that for 10, 100, 1,000 times as many transactions into the same amount of space that it would take you to do 10 transactions on a layer 1. Okay, so that's generally how many layer 2 scaling solutions work. It takes the validity of all this information and stores it into a much smaller footprint on the layer 1 blockchain. Now let's talk about some of the benefits of layer 2 scaling solutions. So these share many of the same benefits as the other EVM compatible chains that we saw in the previous, section, where, if you are an end user, all you have to do is point your Ethereum wallet to a layer 2 endpoint instead of the Ethereum endpoint, and then boom, you can use that application on a layer 2 with very minimal changes. All right. So the other benefit is if you hold Ethereum cryptocurrency or Ether, then you don't need to swap it for a different cryptocurrency to pay the fees on that network. You have to bridge your funds over, all right, to go onto that layer 2. That is an extra step, of course, but you don't need a brand new cryptocurrency to do that. Okay. So the other benefits for you as a developer is if you can create, applications for Ethereum and deploy them with Solidity and deploy them to Ethereum, then you can very easily deploy them to a layer 2 scaling solution. We'll show you how to do that later in this program. Okay. And the final big benefit of these layer 2s is that they piggyback off the security of the main Ethereum chain. So in that previous video where I talked about some of the trade-offs that are made with other EVM compatible chains, is they, in many cases, are not quite as secure as Ethereum itself. There will be some security trade-offs maybe on each individual layer 2, but they still are going to have a robust amount of security that's provided by the underlying layer 1 Ethereum chain itself. Now let's look at some types of layer 2 scaling solutions. So what I really want to focus on are general purpose layer 2 scaling solutions. So what do I mean by that? Well, there are many different types. Some are application specific. You might see this where a specific decentralized application will implement their own layer 2, and then all you can do is use that particular application on that layer 2 scaling solution. I think these have a place and a purpose, long-term in the blockchain ecosystem. But what I'm much more excited about are general purpose layer 2 scaling solutions, which are basically blank slates. They're kind of like blockchains in and of themselves, where developers can take any application they want to and deploy it to these layer 2 scaling solutions. And that's going to have, a rich network effect of applications that you can use and talk to one another that are composable with those environments. So again, if you can deploy contracts to Ethereum, you can deploy those general purpose layer 2s, all right? So the ones that I'm most excited about implement roll-up based technology. And again, that comes from the Vitalik paper that I showed you a minute ago. And the roll-ups design is very similar to what I showed you, or basically is what I showed you a second ago, where you take all the transactions and you batch them up, and then you take the validity of those and you store them back on the main Ethereum chain in a much smaller footprint. Okay, that's really what the roll-up strategy is. And now that falls into two major food groups: the optimistic roll-up strategy and the zero-knowledge roll-up strategy. So optimistic roll-ups, there are several different layer 2s that implement this strategy. One popular one is optimism. So, taken from the optimistic roll-ups name itself. So you can see more info about this on a website like l2beat.com. This is a really great website for monitoring layer 2 scaling solutions. We'll take a look at more here in a minute. But essentially, how optimistic rollups work is they use their own set of validators on its own chain to validate the authenticity of the transactions, and then those are eventually submitted onto the main Ethereum chain, okay? So now one of the trade-offs with optimistic rollups is that there can be a delay withdrawal time. So if you bridge your funds over to this particular environment, it can take multiple days before you can withdraw them off of this. Now, this can be fixed essentially with using a bridge of some kind that helps expedite this process, or using a centralized exchange. But of course, that also has, trust assumptions associated with it. But you can read more about optimistic rollups. I don't want to overwhelm you with too many details on this website here. Okay, so Arbitrum is another example of optimistic rollup scaling solution for Ethereum. Okay, it does a very similar thing to Optimism with some slight differences. Okay, you can kind of read about it here and see, some of the risks involved. Because again, I don't want to act like there's no risks with any of these, but you can clearly see all those on the side here. So let's talk about zero knowledge-based scaling solutions. So ZK Sync is one that I'm excited about as well, okay? So how's that different from optimistic rollups? Well, ZK Sync and zero knowledge rollups uses something called zero knowledge-based cryptography to implement scaling, all right? So instead of having a set of, read layers or validators on this separate chain and trusting those to do the validity of the transactions, you can prove that the transactions are valid with cryptography alone, okay? And a very special type of cryptography called zero knowledge cryptography. And it uses something called validity proofs to ensure that this is correct, okay? So I'll leave these resources for you to read more about this as an exercise, all right? I don't get too far off in the weeds on how this works in depth. This is a situation where you don't really have to know deeply how the car works in order to drive it. Because when you're using layer 2 scaling solutions for Ethereum, it's pretty easy to port your applications over there and use it as an end user. And that's really all you need to know in order to get started as a blockchain developer. But if you want to get a bigger overview of all the layer 2 scaling solutions out there, which ones are gaining traction that you might keep your eye on, or just use this as a further research tool, definitely check out l2beat.com. You can see a list of all the scaling solutions here, what their TVL is, that's total value locked on the network. You can see the type of layer 2 scaling solution. So this is an optimistic rollup. This is a ZK rollup, optimistic rollup, ZK rollup. And then you can see what their purpose is. So Universal is a general purpose layer 2. That's what I was talking about. It's like a blank slate blockchain where you can put any application on it, versus an exchange like DYDX is for this application itself. You can't just write your own app and deploy it to DYDX's layer 2 scaling solution. It only runs and operates this application. So that will help you sort of decode what's here. And then you can click through to any of these and, read about the technology and how it works, what the trade-offs are, what the risks are, and all that type of stuff. All right, so that's an overview of layer 2 scaling solutions and how they work. So later on, when we do the capstone project and we actually create our cryptocurrency exchange, we're going to show you how easy it is to take your application and put it on a layer 2 and use it. But for now, that's an overview of how they work and why they're important as a developer.